Hello and good day everyone. I'm Jon Zeth Aslor, a first-year student from the VCC Aeronautical and Technological College, manifesting to be an engineer in the aviation industry. Today, I'll share you my learning so far in the Introduction to Aviation with Principles of Flight. This covers our topic discussed in class from the first discussion in our prelim term to the last discussion of our final term. And keep in mind, to keep everything short, I'll be summarizing each topic for you to understand. The reason I chose to be an aeronautical engineer is because I was just really curious about how these big machines are able to fly despite their massive weight. And looking back at the evolution of how aircraft evolved, it really did came so far from its current situation. The earliest traces of material where people manifested to try to fly is through the bird-inspired works and sketches of Leonardo da Vinci. However, this was proven impossible as humans aren't really built to fly like a bird. Actually, the very first ever aircraft that the world discovered was through air balloons. Then Sir George Cayley, the father of aerial navigation, built the core of aeronautics through the inspiration of kites and their ability to glide in the air. The world then already knows that flying is possible for humans. But what made the dream to achieve a heavier-than-aircraft work is to the Wright brothers, but with them, the rest is history. Of course, with the power of science and physics, modern aircraft, specifically airplanes, have four forces acting upon it in a straight, leveled, and unaccelerated flight. The four forces of flight can be simplified into two pairs, and each pair contains one positive force and one negative force. The first pair that we have here is the thrust and the drag. Thrust is a positive force that is generated by the power plant, and it is fighting against its opposite force, which is the drag. So drag is actually caused by the aircraft's airflow disruption, and airflow disruption is caused when fluid air hits contact with the surface area of the aircraft. That generates drag. The second pair that we have here is the lift and the wing. Lift is generated mainly by the wings, and this fights against its opposite force, which is the weight. So we know that weight is a negative force that is combined with the entire mass of an object times its gravity. Times the gravity of a planet. So we can say that each planet has different weight for an aircraft too. Before we proceed to a more complex topic of physics and movement related to airplanes, we should first know the different parts of the airplane structure. So, starting off with the wings. Obviously, the wings, as we said a while ago, generates the main lifting force of an aircraft to fly. Then we have here the empennage, or usually where people see it as the tail of an aircraft. So the empennage serves as the longitudinal stability of an aircraft and also used to yaw or to pitch an aircraft. Then we have the power plants. So usually in commercial jets, we usually see the power plants below here, the wings. However, this is a business plane, so we see the power plants usually located below just below the empennage. And we said that the power plant generates the main thrusting force of an aircraft used in taking off or in traveling. Then we have here the landing gears. So as the name implies, the landing gears is used for land operations such as landing, taking off, taxiing, parking, and maintenance. And lastly, we have the fuselage. So it is the biggest part of an airplane, and it serves two purposes. Firstly, it accommodates the people and the cargo. So the people usually are the passengers and the crew, and the cargo usually luggages and cargo, as we said. And the second purpose that we have for the fuselage is it connects everything. It connects every part of an aircraft to one. So it connects the landing gear, it connects the wings, it connects the power plants and the empennage. Basically, fuselage acts as the core of an airplane. Now that we know the aircraft's different parts, it is easier to discuss its three basic movements. What we should understand first is the concept of center of gravity of an airplane. We all know that the center of gravity is the point where an object's entire weight is in equilibrium or is concentrated. Each of these three basic movements has its own axis, enabling them to move at the first place. These axes all align at the center of gravity of an airplane. The first movement is called rolling, and it looks like this. It follows a longitudinal axis of an aircraft that extends from nose to the tail. So let's say that there's an imaginary line that extends from the nose to the tail. that allows an aircraft to roll. And this movement is controlled by moving the plane's ailerons on each wing. And the ailerons is usually located at the back of the wing, and it moves oppositely to each other. So it looks like this to allow an airplane to roll. The second movement is called yawing. So the yawing looks like this. So it just really points the aircraft's nose from left to right. And it follows a vertical axis located vertically on the plane's center of gravity, saying that there's an imaginary line placed vertically in the center of gravity that allows the movement of an airplane to move left to right, or to yaw, basically, like that. Then the final movement, the third and the final movement is called pitching. So pitching is usually used for landing or for taking off. So we can see that pitching usually looks like this. So there you go. It elevates or elevates the aircraft. So it follows a lateral axis, usually located and extended horizontally on each wing. So let's say just like this. Just forward or like this. So I'm assuming that there's a imaginary line there that allows an aircraft to pitch or change its pitch. So pitching is controlled by the elevator that is found on the tail. So it is usually found here in the stabilizers of the empennage. Now let's tackle the subject's main focus. As the name implies, the principles of flight. Flight principles are something that is actually quite hard to explain. That's why I'll be discussing this topic based on my very own understanding. Let's start with how air acts. So we know that gas atoms do not have any definite shape, and their movement bounces off surfaces. You can say that these atoms are more fluid than liquid itself, that even the slightest pressure can manipulate it. Then now, we proceed with how the wings can generate lift and fly the entire aircraft. The wings are airfoil-shaped structures, and when it hits through the fluid air due to thrust, it causes different pressure acting upon between the upper and the lower surface. So the airfoil is actually shaped like a tear. The principle of lift revolves around Newton's third law of motion and Bernoulli's principle of differential pressure. Newton's third law of motion states that for every action, there's an equal and opposite reaction. It revolves around the act of upwash and downwash. Upwash happens in the leading edge of an airfoil that redirects the air upwards. After passing the leading edge, the opposite reaction of downwash pushes the trailing edge down, which is this one, creating an inclination angle of an airfoil. Since this is pushed down, it will increase the inclination angle of the leading edge. Pressure is still present on the lower surface of an airfoil that prevents the downwash from pushing over the airfoil down completely. This is because air is a fluid that can be manipulated. That's why there's still air that can pass through the lower surface of an airfoil. The pressure difference above here and below here now generates lift. Bernoulli's principle of differential pressure focuses more on the difference of air fluid velocity between the upper and lower airfoil surfaces. In his principle, velocity is inversely proportional to pressure. The upper surface experiences faster fluid air than the lower surface. We can now conclude that the upper surface experiences less pressure than the lower surface. Thus, similar to Newton's law of motion, the lower surface of the airfoil experiences high pressure, then creates lift and inclination angle. Either way, both laws states the airfoil experiences a force of circulation to generate lift and angle of attack, which means it revolves around a clockwise motion. That is all for my learning video on how well I understood the lessons that I've learned in WCC Aeronautical and Technological College. I'm very thankful that I was able to learn such a subject earlier than other colleges. This is because I will be switching to another school next semester, due to family decisions. As much as I wanted to stay in this school, I'm very grateful for everything I have received. This bridging subject has already done the job of satisfying my curiosity about how massive machines fly. Still, I found myself desiring to learn more about aircraft instead. May everyone also discover another purpose of learning instead of stopping due to curiosity. And again, I want to thank you, Sir Patrick, for the learning that you have given us. Despite me having a tough time in your subjects urges me to work harder than ever. Godspeed and aim high as the sky.